What we're going to look at here is several different rectangles, and what we're going to find that's interesting about rectangles is it's possible to have the same perimeter with different area, and it's also possible to have the same area but a different perimeter. Let's start with these two rectangles on the left. As we can see here, the area of these rectangles will be equal to 2 times 6, or the top rectangle rather, will be equal to 2 times 6 or 12 inches squared. The perimeter, which we find by adding all four side lengths, and we know rectangles, the opposite sides are equal to one another. When I add all four of these, 2 plus 6 is 8, 8 plus 2 is 10, 10 plus 6 is 16. So that'll give me a total of 16 inches. Now on the bottom rectangle, I have an area of 5 times 3, which is 15 inches squared. And again, when I add in the perimeter, I could see 3 plus 5 is 8, 8 plus 3 is 11, and 11 plus 5 is 16. So what do we see here? Well, we see that both of these rectangles have a perimeter of 16 inches, but the top one's area is smaller. See how it only has 12 inches of area, and this one has 15 inches? So we could see that it's possible to have two rectangles with the same perimeter, but different areas. Now moving over to the other side, the area of this shape I know is 3 times 4, or 12 inches squared. There's the square. And the perimeter of this shape would be, when I add these all together, I would get a total of 14 inches. Bottom, I'd have 2 times 6 is 12 inches squared. And when I add all of these up together, I'd get a perimeter of 16 inches. So here we could see that the area is the same. Both have an area of 12 inches squared, but the perimeter is different. The perimeter in the top one is 14 inches and the bottom is 16. So as you can see, it's possible to have rectangles that have the same area but different perimeter, and it's possible to have rectangles that have the same perimeter but different areas. It all depends on the way that they are laid out.